Okay, this is Pre-Calculus Part 1, Section 4.3, Right Triangle Trig, Example 7 on page 497, Determining the Angle of Elevation. So it gives you the building is 21 meters tall and casts a shadow of 25 meters long, and it wants you to find the angle of elevation. Okay, so the difference here, it shows it to you in figure 4.4, which is down below. So I'm going to move the page down here for just a second. This is backwards from the last problem. Last time they gave us the angle of elevation, they gave us one of the sides, and we had to find the missing side. Now they're asking us for the angle of elevation, and they're giving us two of the sides. So they said the building was 21 meters tall. Hopefully that's where the right angle is, that the building is standing straight up and down. And then the shadow is 25 meters long. And they're looking for the angle of elevation. Well, the angle of elevation for a shadow is the line of sunlight. So assuming the sun's over here and it's casting the shadow over here, which makes sense. Remember, elevation comes from the horizontal and goes up. So we're talking about this angle right here. Since we have the opposite side and the adjacent side, we don't know the hypotenuse. That means we're going to have to use tangent. So tangent is opposite over adjacent, which in this case would be the 21 over the 25. Now, the catch to this one is we can't just use tangent because we don't have something to take the tangent of. So in order to take the tangent, let me get the calculator up here, sorry. In order to clear a tangent, if we want to get rid of the tangent by the theta and solve for it, we're going to have to do the inverse of tangent. It's kind of like dividing to get rid of multiplication. So we're going to do second function tangent of the ratio. So basically we're going to take the inverse tangent of both sides, but the inverse tangent and the tangent on the left side are going to cancel out. So we're going to do inverse tangent of 21 divided by 25. Make sure you're in the mode that you want to be in. And since we're talking about, it asks for degrees, we're going to go ahead and stay in degrees. It gives you approximately 40 degrees. So that tells you that this angle right here is 40 degrees. Okay? You only use inverse tangent or inverse cosine or inverse sine, the one above it, if you are looking for an angle. So for example, checkpoint 7, flagpole is 14 tall and a shadow 10 meters. So it's basically the same picture, only this would be the flagpole and that's 14. The shadow is 10. So we're looking for the angle of elevation. So again, we're going to use the tangent, which I don't know why I did this. I copied the other one instead of putting the new one in here. So it's 14 and casts a shadow of 10. So we're going to take the inverse tangent on both sides in order to get rid of this. Basically we want the tangent to go away, leaving just the theta. So we're going to do tangent, and again, I apologize, I had the wrong problem in here. It should be 14 over 10. And if we put that in the calculator, that's right, it makes me do this one. Okay, so we're going to do second tangent because we want that inverse of 14 over 10. And it's going to give us 54.46, so it's about 54.5 actually. It says to the nearest degree, so we'll call that 54 because it was 54.4. So your answer would be 54 degrees. There we go. Okay.